Problem. A ball is dropped from a height of 16 feet. At every bounce, the ball reaches a height of 75% of its previous height. What is the total vertical distance traveled by the ball over an infinite period of time? At first glance, this problem seems very strange, as the ball moves over an infinite period of time. However, it is possible to neglect this issue using some creative math techniques. Our first step should be trying to express the vertical distance of the bouncing ball. The problem statement mentions the ball bounces 75% of its previous height. Therefore, we can write the vertical distance of the ball traveled as 16 plus 16 times 3 over 4 plus 16 times 3 over 4 squared plus 16 times 3 over 4 cubed, and so on, because it is over an infinite period of time. The reason we are raising 3 over 4 to certain powers is because we are continuously multiplying 16 by 3 over 4 after every single bounce. If you have encountered problems similar to this, you may recall that this problem is asking you to find the sum of an infinite series. For those of you who do not know what an infinite series is, it is a series that can be expressed in the form x plus a times x plus a squared times x plus a cubed times x, and so on. The formula for calculating the sum of an infinite series is x divided by 1 minus a. In case you do not know where the formula came from, we can derive it using some simple arithmetic and clever algebra. Let us define the variable s as the sum of the infinite series. So s becomes a squared times x, a cubed times x, and so on. Now let us multiply both sides by a. So we get s times a is equal to a times x plus a squared times x plus a cubed times x, and so on. The reason we get these values is because we multiply each of these terms by a. Now the really interesting part of the derivation comes into picture. What if we subtract s times a by s? If you look at both the equations, this is the equivalent of crossing out every single term except for x. Our equation now becomes s times a minus s is equal to negative x, because this value stays there. We can factor out s and we get s times a minus 1 is equal to negative x. S can be rewritten as negative x divided by a minus 1, or x over 1 minus a, which is where we get this formula. Now let's apply it to the problem. Our equation requires an x and an a. If you look back, a is 3 over 4, as this is the number we're raising to a certain power, and 16 is our x, as this is our constant that we keep multiplying by. So after plugging this into our equation, we get 16 over 1 minus 3 over 4, which is equal to 16 over 1 over 4, which is equal to 16 times 4, or 64. You may think this is the answer, but no. Remember, a ball has to go down and then up. Take a look at this diagram. Let's say that this was the ball. After being dropped, it travels in this path, bounces 75% of its initial height, goes down, bounces, and so on. So notice how there are two components for going up and then going down, which means that we have to multiply 64 by 2. However, we are not done yet. Notice how the ball only goes down by 16 feet once, not twice. So after multiplying 64 by 2, you have to subtract 16 to compensate for overcounting. So 64 times 2 minus 16 is equal to 128 minus 16, which is equal to 112 feet. This is our final answer. Thank you for listening.